Hello.
Yes, sir.
Okay. We'll continue from last class. The last thing that we did was isogonal conjugate of a point P. And I had asked the question that out of these points, which ones are isogonal conjugates of each other? Orthocenter, 9-point center, centroid, and circumcenter.
So can you first explain this 9-point center?
9-point center is the midpoint of orthocenter and circumcenter, and it is the center of a circle that passes through 9 points. What are those 9 points? 3 foot of the altitudes, right?
Mm.
3 midpoints of the sides, and 3 midpoints of these segments. If you look at this orthocenter edge, midpoint of this, midpoint of this, midpoint of this, you can already see it is roughly a circle.
Yes, sir.
So this is the circle. Something like this. This circle has a center, and the center is the midpoint of orthocenter and circumcenter. Orthocenter and circumcenter lie on a line. The center is here, N. And obviously orthocenter, centroid, and circumcenter, all 4 of them lie on a line, right?
Yes, sir.
Yes.
9-point center is the midpoint of the line. So it is like this, ONGC. This is 2, this is 1, 2:1, and this is half, and this is half, 1:1. Do you understand?
Yes, sir.
Anyway,
Yes.
the proof of this and all we will see later, or if you have done chapter 15 in Thessaloniki, the proof is there. That 9-point center, what is 9-point center, everything is there.
Yes.
But that is not the point right now. The point is which ones are isogonal conjugates. It is very easy to prove that orthocenter and circumcenter are isogonal conjugates of each other. How do you prove that? You can try to take the angles that are there and figure out whether they are reflection of each other across the internal angle bisector. If you see ABC, this is my altitude, and let's say circumcenter is here, orthocenter is here, and this line is AO. What I need to prove is that AO and AH are reflections across the angle bisector, right?
Yes,
Yes.
sir.
Then you will know that O and H are isogonal conjugates of each other. So we already know this much angle is 90 minus B. We know that this angle will be how much? This much will be 2B, right?
Yes, sir. So
Yes.
90 minus B.
So it is done because the bisector divides it in A by 2. The bisector is going to make A by 2, A by 2. So this angle is A by 2 minus this, and this angle is also A by 2 minus this.
Yes,
So it is obvious that it's a reflection.
yes, sir.
Does everyone understand what I'm saying?
Yes,
Yes.
sir.
So orthocenter and circumcenter are isogonal conjugates of each other. The isogonal conjugate of in-center is in-center itself. because you cannot reflect it across internal angle bisector, it will stay there,
Yes.
right?
Yes, sir.
Okay. Next thing is proof of Menelaus. So Menelaus theorem says let ABC be a triangle and let A1 belong to BC, B1 belong to AC, and C1 belong to AB, such that exactly one or all three of A1, B1, C1 lie outside the segments, lie outside the segments BCCA AB. Then, if this is true, then we can say that A1, B1, C1 are collinear points if and only if A1B by A1C times B1C by B1A times C1A by C1B is equal to 1. That is your statement of Menelaus. We will do a proof of it. This is A.
Sir, by putting perpendiculars
Hmm.
and then similarity.
Perpendiculars नहीं, पहले parallel line बनाना पड़ेगा. So first we will say we'll draw the figure. A1 belongs to BC. Let's say A1 is outside the BC segment, and that is the only one that is outside. Exactly one wala case. And the other ones are on the segment. So we'll say, let's say this is B1 and this is C1. I want to prove that these 3 points are collinear, right?
Yes, sir.
So we will draw a line through them, or we'll assume they are collinear and prove the condition. It will work in both sides, so we'll assume they are collinear for now. We draw a line like this, and we'll draw also a line parallel to BC through A. So that is the standard technique for both Seva's theorem and Menelaus theorem also. So once we draw this parallel line here, we will get similarity. This is the point of intersection X. I can say triangle AXB1 is going to be similar to triangle A1B1C, right? Similarly, I can say triangle AC1X is similar to BC1A1, right?
Sir, एक मिनट wait.
And yeah, so from these you will get the appropriate ratios. From this, you will get ratio B1C by B1A is equal to A1C by AX. And from here, you would get C1A by C1B is equal to AX by A1B. And then if you try to calculate this 3 products, you will realize that they will cancel and become 1. These 2 similarities are enough
Yes,
along
sir.
with their relevant ratios. These are obvious similarities. There's no need to worry about it also. This triangle is obviously similar to this triangle, and this triangle is obviously similar to this big triangle. Because of the parallel lines, it is happening. Now, one thing to remember here is how do we write this condition if you want to apply Menelaus? So, while applying Menelaus, even if the points are outside, you should imagine mentally that the points are inside. So the point is A1 is outside the segment. I will imagine it somewhere here. And now see what I am doing. A1B by A1C, then B1C by B1A, then AC1 by C1B, right?
Yes, sir.
So even if they're outside, imagine them to be inside, and then in a sequence, just like Seva's theorem, you have to go in a one order, right?
Hmm.
And if you do it in correct one particular order without breaking the order, you will get the right sequence of sides. Is it clear how to write the condition?
Yes,
Yes,
sir.
sir.
Proof is by similarity. The condition you need to know how to write. Okay.
Yes.
So that is very important. If you can't write Seva's and Menelaus conditions, then it will be difficult to solve any problems. You need to know the order. It always is in that order. You can start from anywhere. It will always be correct. Right?
Hmm. Hmm.
I could have started from B1C by B1A, then AC1 by C1B, then BA1 by A1C. Right?
Yes, sir.
Okay. Now, the next thing to prove is the very common result that you have used forever. Centroid divides the median in the ratio 2:1. This one and the next one, and even the next one, the next three proofs will show you why Seva's and Menelaus theorem are super important.
Okay.
Draw a triangle A, B, C, and draw medians right. Correct. This is the situation. These are medians, right?
Hmm.
I want to prove that the G point is AG by GM is 2:1. That's what I want to prove.
Yes, sir.
AG by GM is equal to BG by GM is equal to CG by GP.
Yes, sir.
So think about it, what you can do here.
Hmm. Done.
Sir, by Seva or Menelaus or
नहीं,
by
मैं
triple
Seva
J?
or Menelaus?
अच्छा बाय सेवा और मेनेलॉस
Yes,
Okay.
obviously.
ऐसे मैं तो बेनोस की कर लूँ बाय सेवा Hmm.
Look at triangle ABM and look at the 3 points C, G, and P.
CGLP. Hmm. अच्छा ओके यस सर
C, G, and P is clearly a
हाँ
collinear situation.
यस सर
So
यस
we
सर
can
यस
apply Menelaus and we can say, we'll imagine the C point lying outside to be somewhere here. And we can say CB by CM multiplied by MG by GA multiplied by
हाँ
AP by PB should be 1 by Menelaus.
CB is equals to 2
CB by CM is clearly 2.
into MG by GA
MG by GA we don't know.
into AP
And
by PB is 1
AP by PB is 1. So we are
so
getting
MG by
MG by GA is
1 by 2 then hence proof EBC.
obviously you can think of a different triangle and 3 different points and get the other ones also.
Yes sir
So this is a one-step proof by Menelaus.
Yes.
That's what I want you to realize. The normal
yeah
proofs will be longer. And mostly you need to learn how to apply Sevas and Menelaus in different situations. That's why we are practicing it.
Hmm.
Is everyone clear on what we did here?
Yes, sir.
रुद्रजी समझ में आ रहा है ना सब? Okay, fine. The next one is the Euler line, which we just discussed. We'll say the centroid G lies on the line OH, where O is circumcenter, H is orthocenter. So first thing is this, centroid lies on this line. We have to prove that. And also secondly, we have to prove that HG is equal to twice of GO. So centroid divides them in the ratio 2:1 also we have to prove. So far we don't know that centroid lies on this line. We have not done the proof of that yet. This is the rough figure. O is circumcenter, H is orthocenter, M is obviously midpoint, and D is the foot of the altitude. And let's call this point of intersection the point of intersection of median with the line OH. Let's call this point G dash for now.
Which, sir? अच्छा ये वाला.
M is midpoint of BC, D is foot of the A altitude, G dash is intersection of AM with OH.
Hmm.
It would be done if you can prove that G dash is centroid, right?
Hmm.
So, okay.
This is the line passing through BG dash bisect AC. Then it's over.
We are not going to draw anything more in this. We want to show that G dash is centroid, because that will mean that centroid lies on the line OH. So one way to show that G dash is centroid is that if we can prove that A G dash by G dash M is 2:1, then G dash is centroid, right?
Yes, sir.
Because we already know that AM is a median. So any point that divides in the ratio 2:1 will be centroid, right?
Hmm.
Okay. So we want to show this AG dash by G dash M is 2:1. If you remember SL only, then we know AH distance. What is AH?
R
2R,
cos A.
2R cos A.
2R
Yes.
cos A, not R cos A.
2R cos A.
What is OM?
OM.
Draw a separate figure just with circumcenter. O is here. Obviously, OBC is 2A, right?
हाँ,
तो ये एंगल AA है, तो OM is obviously R cos A.
R cos A. हाँ, sorry.
Is everyone understanding why OM is R cos A?
Yes, sir.
Yes.
अच्छा, उनका ratio 2:1.
Right. Now we can prove that this triangle is similar to this triangle. Triangle OG-M and triangle G-AH are similar.
AA property.
One angle तो obviously similar है, और दूसरा
फिर
चीज तुम
parallel
बोल
to
सकते हो कि OM is parallel to
हाँ,
AD.
AD.
OM is parallel to AD because both of them are perpendicular to the same line. So if OM is parallel to AD, then this angle will match this angle. So the triangles are clearly similar, right? If the triangles are similar and one of the ratios is coming 2:1, AH and OM, दिख रहा है ये रेशियो इसका और इसका
Yes, sir.
2:1 रेशियो आ रहा है, right? They are corresponding sides
Which
because
is
both
AD.
of them are opposite to the vertically opposite angles. So
Same as
2:1
AD
यहाँ पे आ
and
गया, तो इससे ये भी पता चल गया कि AG' by G' M will be 2:1,
2:1.
which means G' is centroid, which also means G'(H) is 2 times of OG'.
Yes, sir.
So which also proves that GH is twice of GO. Is everyone understanding? Everything is done.
Yes.
It's just some similarities. You just have to draw this figure carefully and realize these two things, and that's it, similarity. Okay. The next thing is Van Aubel's theorem. Point number 21. So here we say let ABC be a triangle and let P be an interior point of this triangle. Let the lines AP, BP, CP meet the sides BC, CA, AB at A dash, B dash, C dash respectively. You have to prove PA by PA dash is equal to C dash A by C dash B plus B dash A by B dash C. Draw the figure and try it out. I won't say anything. This is the figure roughly, something like this. P can be anywhere inside the triangle. I have drawn it in this place just because it makes it look convenient. It's not like it's perpendicular or something. I hope everyone is understanding that.
Yes, sir. I was thinking of using Menelaus theorem in triangle AB A dash. So we
Triangle
will get
AB A dash. You can
hmm.
use the points C dash, P and C.
हाँ हाँ तो उसमें Menelaus तो फिर वही हो जाएगा कि P
CB by CA dash
CA
multiplied by A dash P by PA
CA
multiplied by
AC dash by C dash B is equals to 1.
okay. This is the result. So
Hmm.
from here, one advantage is that we can at least isolate this ratio.
Yes, sir. So A dash P by P dash A.
We are getting this is equal to is coming as the reciprocal of these. So C A dash by CB multiplied by C dash B by AC dash.
नहीं सर वो जो आपने लेफ्ट हैंड में लिखा है वो आपने उल्टा कर दिया है.
सही तो किया है. ओ
हाँ तो
गलत किया
रेसिप्रोकल ही
है.
होगा ना.
सर ऊपर उल्टा हो
गलत
गया.
कर दिया. PA has to go here and P dash P, this has to go down. So this will remain same.
CB by CA dash into AC dash by C dash B.
Okay. So we know at least this much. We need to prove now this is same as this.
Yes, sir.
Okay.
So can I rejoin? थोड़ा network issue हो रहा है.
तो ध्रुवजीत समझ में आ रहा है. रेसिप्रोकल नहीं हो रहा है, बस इसका रेसिप्रोकल कर रहे हैं. इसको उधर ले गए, इसको छोड़ दिया जैसे था. दो दो दूसरे वाले ratios are remaining there at their place. We have just taken reciprocal of PA वाला term. अब इसमें आगे क्या कर सकते हैं. इसमें यहाँ पे तुम देखोगे कि C dash A और B dash A है. Okay, we don't need to worry about that first. What we can say is that at least the CB we can write as A dash B plus A dash C, right?
Yes, sir. A dash B plus A dash C.
Because then we'll get CB by C A dash is equal to A dash B plus A dash C by, this is A dash C only.
A dash C.
So this is 1 plus A dash B by
A
A dash C.
Hmm.
So now we are getting PA by PA dash is equal to 1 plus this thing multiplied by this thing. So we can multiply with that AC dash by C dash B plus AC dash by C dash B times A
Times
dash B by
A
A
dash
dash C.
A dash C. Yes, sir.
So far we have this. So notice that this term is already matching now, right?
Yes, sir. Now we have to make that as B dash A and upon B dash C. Now, sir, I think we will do here Siva's theorem.
Hmm.
B A
We
dash into A dash C. B A
will
dash upon A dash C into C B
into
dash into
Seva's theorem for the three lines A dash, B
mm,
dash,
and
C
AB.
dash, which are concurrent at P.
C. Yes, sir. Then we will get the same ratio. We that
We will
this
get A dash B by A dash C times
A
C
dash
B dash by B dash A times A
A.
C dash by C dash B is 1.
Now, sir, we know that we have got
A
हमारा
C dash
equation
by C dash B यहाँ पे है.
and A dash B by A dash C भी है तो फिर वो बचा है सर उसको आइसोलेट कर देंगे उधर तो वो
The product
A
of these two is clearly B dash A by B dash
by
C.
B dash C तो
So
आ
we
गया सर
replace this with B dash A by B dash C,
proof
and then we're done. So basically the proof happens if you do Menelaus in one triangle and the Shevas for the three lines A dash, B dash, and C dash. Is it clear? Everyone is understanding what I'm saying?
Yes, sir. I was searching for another Menelaus so that we can have another PA by PA dash, then we can substitute, but I'm not able to find it.
It's fine. ये वाला यहाँ तक अगर हो गया तो उसके बाद फिर बस रेशियो को
Yes,
थोड़ा सा
sir.
मैनिपुलेट करना है.
वो अच्छा था सर
Okay. The next theorem is slightly tougher, but it is quite useful sometimes. Desargues theorem. It says let ABC and A dash, B dash, C dash be two triangles. Then the lines A dash, B dash, C dash are concurrent if and only if the intersections of BC and B dash C dash of CA and C dash A dash and of AB and A dash B dash are collinear. So this is a collinearity condition of 3 points, right? So the theorem is very powerful because it is converting a concurrency condition. Here, these are three lines. Three lines are concurrent if 3 points are collinear, right?
डायग्राम बना सकते हैं सर थोड़ा समझ में नहीं आ रहा
डायग्राम बना सकते हैं. डायग्राम बनाने में क्या मुश्किल है? Write down the proof theorem first.
लिख लिया सर
सबने लिख लिया.
Yes, sir.
So, okay, so now we will draw a rough diagram. There are two triangles in the plane. Let's say this is ABC. And there is another triangle here, let's say. A dash, B dash, C dash. So we have to join A dash, that's a line, B dash.
also aligned
Okay, I have drawn the triangles in such a way that the lines look parallel, so it will be difficult. So we should make the lines in such a way that they look concurrent, right? So because then the figure becomes very long, very big.
सर बी को
So
फ्लिप कर दीजिए.
no, I want it to be like this and meet
अच्छा.
here, right?
हाँ हाँ.
So this will become my C dash, this is A dash, and this is B dash. So first part of the theorem was saying that the lines A dash, B dash, C dash are concurrent at point P if and only if. Now the second part of the theorem is about the collinearity of what? Of the intersection of BC and B dash C dash, right? So BC side intersection with B dash C dash. So one point is here by the way, right? थोड़ा सा डायग्राम में तुमको लेबलिंग सही से करना पड़ेगा. तो BC और B dash C dash का एक इंटरसेक्शन यहाँ पे है, राइट?
हाँ.
इसको X बोल सकते हो. फिर
Yes.
AC and A dash C dash था. AC and A dash C dash. तो AC X से एक्सटेंड हो रहा है और A dash C dash ऐसे है, राइट? नॉट रियली. A dash C dash यहाँ से ऐसे जाके ऐसे आ रहा है और AC ऐसे आ रहा है, राइट? डू यू अंडरस्टैंड व्हाट आई एम सेइंग?
यस सर. लेकिन सर वो
Yes.
ए बी और ए डैश बी डैश वाला केस थोड़ा लंबा हो जाएगा इसमें.
हाँ, लंबा तो हो जाएगा लेकिन अब कुछ और किया नहीं जा सकता है. वी डोंट नीड टू ड्रॉ एवरीथिंग टू प्रूव इट.
अच्छा.
डू यू अंडरस्टैंड व्हाट आई एम सेइंग?
यस सर.
यहाँ से ये कहीं पे होगा इनका इंटरसेक्शन
हम्म.
ए बी और ए डैश बी डैश का. दे लुक पैरेलल, दे शुड नॉट हैव लुक पैरेलल. So you can alter the diagram a little bit to make it not parallel. थोड़ा ऐसे ट्विस्ट कर देंगे, राइट?
यस
Yes,
सर.
sir.
थोड़ा ट्विस्ट कर दोगे तो एक्स वाई का ओरिएंटेशन भी थोड़ा सा चेंज हो जाएगा और मीट किसी इस तरफ मीट हो जाएगा कहीं पे. समझ में आ रहा है मैं क्या बोल रहा हूँ?
यस सर.
Yes, sir.
पॉइंट ये है कि इन तीन लाइंस का ए वन ए डैश बी डैश सी डैश का कॉन्करेंसी इज इक्विवेलेंट टू the points x y z का collinearity where x y z are what? The intersection of
AC and AC dash.
हाँ,
Sorry,
AC and A dash C dash sides
वो सर
BC
वाई है वाई. हाँ मतलब वही.
and B
B
dash
dash.
C dash or C A B and A dash B dash.
हाँ.
We can label it whatever, doesn't matter.
अच्छा.
इनका इंटरसेक्शन दोनों ट्रायंगल्स के करस्पॉन्डिंग साइड्स का इंटरसेक्शन है, राइट? उनका जो भी पॉइंट ऑफ इंटरसेक्शन
Yes, sir.
आएगा उसका कोलिनियरिटी इंप्लाइज दैट दोनों के वर्टेक्स को अगर ज्वाइन करोगे तो वो कॉन्करेंट हो जाएगा. सो इट्स अ वेरी पावरफुल स्टेटमेंट जो सोच के भी समझ मतलब यू कैन एक्सप्लेन द स्टेटमेंट ऑफ द थियरम इवन इफ इट इज हार्ड टू ड्रॉ द डायग्राम. You should be able to understand the theorem and state the theorem correctly because then only you can use it. Is everyone understanding the statement?
Yes sir.
Yes,
Okay.
sir.
So now in order to prove it, you will need to do Menelaus 3 times. Okay. So ultimately हम लोग ऐसा मान सकते हैं कि we want to prove x, y, z are collinear, right? We want to prove that x, y, z are collinear. So notice that x, y, z are all outside the triangle, right? In triangle ABC.
Yes sir.
Yes.
Z भी कहीं इधर कहीं पे हो रहा था, right?
तो we can
हाँ.
do the Menelaus in
हाँ,
triangle.
we can do the Menelaus in triangle ABC.
हाँ.
So Z in triangle ABC. All three are outside. Assume they are inside and write the distances appropriately.
AX upon XC.
No, X is on, I think, BC, right?
Sorry, yes sir.
So you will say XB by XC, right? Then YC by YA.
CYYY. Then
And then
AZ YZB.
this condition we need to prove. ये कंडीशन समझ में आ रहा है सबको? रुद्र जी तुमको समझ में आ रहा है? Basically, we are saying XYZ are points on the extensions of BCCA AB. All three are outside. We will mentally put them inside and write the condition of Menelaus.
हम्म,
And that is what we want to prove,
हम्म,
right?
yes sir.
Okay. But then what the information do we have? We know that these are concurrent and all, right?
Yeah.
We know that these are concurrent at point P, right?
हम्म,
So the way you do it is, what you can do is in triangle PBC, right?
P, B and C. अच्छा.
In triangle PBC, we have to use P because that is the concurrency point here.
Yes sir.
We have to use it because otherwise we'll not be using the concurrency condition only, right?
हम्म,
This is the assumption. This is what you need to prove, right?
हम्म,
In triangle PBC, we can do Menelaus for the points B dash, C dash, and X.
yes.
Think about it.
Yes.
Yes sir.
B dash
हाँ
यहाँ पे है,
हाँ
right?
C dash उधर है.
यहाँ
Yes.
पे है. और
हाँ
वेट, C
C
dash
dash
कहाँ पे था? C dash
ये
कौन सा
रहा.
था मेरा?
सर ये
सर
जो
यहाँ
हाँ
C
ये
dash
था,
से
ये था,
पहले.
ये है.
वाला C dash
Yes
है.
sir.
हाँ
हाँ, C dash
ये.
यहाँ पे है और
हम्म,
X, right?
yes sir.
So notice that PBC पे कर रहे हैं.
वो तो कॉन्करेंट है ही है वो तो
नहीं
बाई.
नहीं, Menelaus करना है.
हाँ वो तो हो जाएगा सर जैसे कि B डैश बाई.
नहीं, कंडीशन नहीं पूछ रहा हूँ, मैं बोल रहा हूँ कि इमेजिन करो, विजुलाइज करो कि Menelaus अप्लाई हो सकता है कि नहीं इस ट्रायंगल.
सर क्योंकि वो जो BC का इंटरसेक्शन ही तो X है और सर वो तो तीनों पैरेलल ही है.
No, X is outside and C dash and B dash are on the triangle.
लेकिन सर आप ट्रायंगल PBC का कर रहे हैं तो वो BC की तो एक्सटेंशन ही तो है X पे तो
तो
आराम
वही तो
से.
आउटसाइड है.
हाँ तो वही लग सकता है सर कोई दिक्कत नहीं दिख
मैं
रही
वही
है.
बोल रहा हूँ कि लग सकता है कि नहीं, वही देखना है ना कि वन ऑफ देम हैज टू बी आउटसाइड और ऑल थ्री हैव टू बी
हाँ
आउटसाइड. लग
हाँ.
सकता है, उसके बाद रेशियो लिखना मुश्किल नहीं है. लग
Yes.
सकता है कि नहीं वो देखना है ना, वही मेन है.
तो
Yes.
फिर ये
इन
प्रूफ करना.
इन ट्रायंगल PBC you can see that BC, B dash, C dash, X are valid points to apply Menelaus, right?
और सर लेकिन ये भी प्रूफ करना पड़ेगा ना कि P डैश C डैश एंड C आर कोलिनियर. अच्छा वो तो कोलिनियर है ही है. सॉरी सॉरी.
वो सब
हाँ
नहीं
तो
प्रूव
फिर.
करना पड़ेगा.
हाँ वो तो फिर लग गया सर. फिर तो लगता ही है कोई.
सिमिलरली तुमको PCA सेम चीज रिपीट करना है. PCA में तुमको देखना होगा C डैश, A डैश और Y पे.
भाई के लिए हाँ वो भी
और
दिख रहा
सिमिलरली PAB में देखना होगा.
PAB.
PAB ट्रायंगल में A डैश, B डैश और Z पे.
है. E डैश
Oh yes sir.
तुम
और
फिर से
Z.
अच्छे से फिगर बनाना और देखना कि ये सब तीनों
हाँ
मेनोलॉज
वो.
लगना चाहिए.
हाँ हाँ
Yes sir. क्योंकि यहाँ पे Z दिख नहीं रहा है तो.
हाँ.
यहाँ पे दिख नहीं रहा है क्योंकि मैंने ठीक से ड्राइंग नहीं किया था.
अरे कोई
हम्म.
बात नहीं तो
Z is
आगे
on the
चलो.
extension of AB.
हाँ हाँ
Yes sir. Yes sir.
कोलिनियर.
तो ये तीन मेनोलॉज का तीन तीन कंडीशन आएगा. तीनों कंडीशंस को अगर मल्टीप्लाई करोगे तो ये हो जाएगा. तीनों मेनोलॉज का तीन तीन कंडीशन आएगा विच विल बी वन
Yes
वन
sir.
वन,
Yes sir.
राइट.
Yes.
तीनों को मल्टीप्लाई करके देखना तो हो जाना चाहिए कि ये हो जाएगा वन.
यस सर.
सो ट्राई इट आउट एंड फिनिश द प्रूफ.
यस सर.
After that, we have couple of important theorems and then we'll come to Simpson's line and all. So all of these are well known to students who are serious candidates. So you need to also know it. This is definitely not going to be required for RMO and all. It will be at a slightly
Hmm.
higher level we are doing. But
Yes sir.
the point is not that you have to remember all these theorems. The point is कि करने आना चाहिए Menelaus और Sheva different different situation में.
हम्म.
If you
Yes.
know how to do it, then many questions at lower levels will be easy.
Hmm.
So we are doing it for practice and to understand Shevas and Menelaus in all of these situations.
Yes,
Okay,
sir.
so
Yes.
fine. Try to finish this proof. We'll continue with the rest of the theory in the next class.
Okay,
रुद्र
sir.
जी तुम पूछ रहे हो कि क्वेश्चंस कब देंगे, तो लेकिन अभी तक तो क्वेश्चन तुमने बनाए हैं, 270 तक था, क्वेश्चंस बना लिए सारे। तो वो 270 तक शीट था, वो तो बनाया नहीं होगा तुमने। क्वेश्चंस और मांग रहे हो। क्वेश्चंस का कमी नहीं है, बहुत सारे क्वेश्चन मैं दे सकता हूँ लेकिन जो पहले दिया हुआ है वो तो बना नहीं है। अभी थियरी पे ध्यान दे रहे हैं, क्वेश्चंस करेंगे फिर कभी ना कभी। Theory has to be finished to a decent level first. Anyway, that's all for now. I'll see you in the next class.
Okay.
Thank you,
Bye.
sir.